Hi guys, so for this video I want to go through a few like 3D sort of problems that involve trigonometry, in particular just the SOHCAHTOA, just to keep it relatively simple. A lot of these 3D problems, typically you can break them up into just right angle triangles, so that just means SOHCAHTOA, you don't have to worry about sine rule or cosine rule, etc. Okay, so find the angle between a slant edge and the base in a square pyramid, which has a height of 8 meters and who has base side lengths of 12. So we're trying to find the angle between a slant edge. A slant edge is an edge which is not flat nor vertical. It's on a slant. So an edge, remember, is like some of these lines of this pyramid. So that's like a slant edge. That's also a slant edge. That one there. That's one there as well. We want to find the angle between one of these sorts of lines and the base. Now, we got to think to ourselves, how are we going to go about this? Now, it's really important to be able to visualize these sorts of objects to be able to answer these sorts of questions. So they help you out with a bit of a diagram here. So here they've got their angle that they're trying to find. They've actually highlighted it for you. This angle here, note that it's in between the slant edge here along the side and a line along the base. They actually go straight through the middle, and in between these two highlighted lines, that is our theta. Okay, so how do we figure out this theta at the moment? Well, firstly, we need to think to ourselves, we've got to try and get this theta into some sort of right angle triangle. So if I use my height here, suddenly, and I get rid of this that part there, suddenly we can deal with this right angle triangle here, because this line is vertical, that line is flat. Sorry, I'll use a highlighter. So this line is vertical, that line is flat, so it's definitely a right angle triangle. Okay, so let's try to work with this right angle triangle here. Now we know to figure out our theta, to figure out what this angle is here, we need to know two side lengths. So we know one, but we don't know this length here. But we can use Pythagoras to help us out. So the next thing I want to look at is the way that we're going to figure out this length here is by using this length here and this length here, because they are going to make and I'll do this in a different color, this length here and this length here at right angles. There's a right angle there, and that's going to make a right angle triangle all the way across there along the bottom. So we can use the 12 and 12 to figure out the length from A to C. So let's do that. So we've got that A squared plus B squared equals C squared for Pythagoras. Let's say that AC is our hypotenuse. So AC squared is going to be equal to 12 squared plus 12 squared. So 144 plus 144 equals AC squared. That's 288 equals AC squared. So, and then AC equals the square root of 288. So that's our value for AC. Now, we want to know the length of this right angle triangle. We want to know from A just to the middle. So it's literally going to be just half of this AC. So our middle is M. So therefore AM is going to be equal to the square root of 288 over 2. It's being divided by 2. We've only got half. So this is the sort of working that you need to be doing. So now that we know this bottom length here, sorry, I'll use a highlighter. Now that we know this length from here to here, it's this, we can use that to figure out our theta. So looking at this triangle here, we're going to have to use opposite and adjacent for our tan. So that means we're going to be using tan. So tan of our theta is equal to opposite is 8. And the adjacent is down the bottom here from here to here, this length here. And that is equal to this thing here, so that can go on our bottom. So I've got, I'll do this in lighter blue. I've got root 288. Let's get a smaller pen. Sorry, guys. So root 288. Sorry, guys. Square root of 288 over 2 is our adjacent. We can put that into our calculator. Sorry, we'll leave it like that for now. It's a little bit messy having a fraction. Having a fraction within a fraction, but it's still okay. And now to get theta by itself, we have to do inverse tan. So tan minus 1. And inside we're going to put this lovely fraction in a fraction. And we get our answer. So if we put that into a calculator, you'll end up getting your value of theta. And it should end up being roughly something along the lines of 43 degrees and 19 minutes. So that's what we should get from this sort of from this working. Okay, so let's try the next one. So in the pyramid of example 7, so this pyramid again, find the angle between an oblique face of the pyramid and the base. So an oblique face is one of these faces that's kind of still on a slant. So if I try to colour in this face here, that's what you would call an oblique face. Now we want to know the angle between this sort of face here and the base. So the only difference between the first question and this question, they want the angle between this face here and the base, but over here this was just the slant edge. So very similar sort of questions, but they are going to give us different sort of results. So let's have a really good look at this triangle here. Now just a reminder that that is 12 along here, and that is a height of 8 still. Okay, so we want to figure out the angle between this sort of face and the base. So if I colour in the base and that sort of side, so what would be the angle between them? So the way to do that is to try to visualize this sort of triangle within the triangle. So we want to go to the middle of our this face, and we want to work with this sort of triangle. So that's going to be a right angle because that's a flat line right here, and this line going up here is perfectly going straight up, so it's going to be definitely a right angle there. Okay, so we want to think, what is the angle made? So we're thinking about what is this theta right here. Okay, well, we know that each side length is 12. So we know that that length there is 12. So from this point here to the center is literally just going to be half of this 12. So we know the bottom of this is just a 6. So that helps us out with that triangle. So I'll put a 6 down here. And we know that from the middle straight up to the top is 8. So we can use these two values in this right angle triangle to figure out our theta. So in this right angle triangle, you're going to be dealing with 8 and 6. So our opposite is 8 and our adjacent is 6. So this is a nice quick one. We can think tan theta, opposite over adjacent is 8 over 6. And therefore theta is tan minus 1, 8 over 6. And that gets us our answer. So if we have a look, that should come out as something along the lines of 53 degrees and 8 minutes. So these questions are tricky. I won't be giving you too many for this lesson, but see how you go. You try to use this video to help you out as much as possible. Good luck. See ya.